Welcome. What we're going to talk about today is a couple of common themes that we get questioned on. The first one is which control unit will work with the valves that I have, for instance. And then the second one, which is somewhat related, is how do I know where the problem lies within the system itself if I do have a problem with the control box or things along that line. So I'm going to address the first question, or the first item that I listed, which is which control box do I need for the valves that I may have on my unit? And the answer to that simply rests in which type of valve do you have. Solenoids are typically a two-wire, so they're going to have two connection points, a negative and then a switching point for the positive wire. And a ball valve configuration is actually going to have three connectors to it. It's going to have a positive, a negative 12 volts, and then it's also going to have the switch wire included in it. Now, the reason that is an important question and answer is that control boxes, TIR, as well as everyone else, needs to wire the control box different between a two-wire and a three-wire configuration. So we want to start out with the correct control box to begin with. So what we're going to work on today is solenoid control boxes for the troubleshooting aspect of it. It's just a simpler way to go through it, but we're going to cover the same things that can be used in a motorized situation. So with that, for troubleshooting, it's best to have like a multimeter. You may not have access to one. We can test it live with a simple light, a test light. You will need, with the test light, you'll need some sort of a power supply, a battery, possibly even a battery charger. The requirements would be, though, that you need something that's going to supply the 12 volts with somewhere between 5 and 10 amps of power available. So with that, we're going to go ahead and get started, and there's two types of testing, as I alluded to before. There's ohms or resistance testing, and then there's the live testing with the power, and we're going to start with the ohms or the resistance. So with that, we're going to take the meter. Well, the first step, is to make sure that your power is completely disconnected from the source. And the reason for that is the meter is going to have a 9-volt battery inside, and the 9-volt battery is actually going to make and break the circuit that the meter is actually looking for. So when I touch my probes together, that makes a circuit, and I have it set for continuity so that it's actually making a tone so that it makes it easier to test. I don't have to look at the number display to figure out whether I've got a circuit or not. So from there, we're going to start with, we're not sure if the control box is actually good or if we've got a problem within the control box. So what we're going to do is we're going to turn all the switches on, and then we're going to take one of the leads, which we're making the circuit, so it's not going to matter whether we hook the red to the red, the black to the black. We just need to hook one probe tip to one wire, and then from there we're going to go ahead and we're going to probe all the way to the other end of the circuit, which is the plug, and we're going to push this in, and we get a tone. So that means that this first wire, which is the brown one, is somewhere connected to the positive. The second wire, which is the black, is also hooked to the positive. The green one, nothing. The yellow one, nothing. The blue one, we get a tone, so that's a positive. And the red one is nothing. So now we're going to repeat the process because we know we've got three wires that are tied to this red one. We're going to repeat the process with the brown or the ground wire. And we're going to go ahead and connect that. We know what three are. We're going to start at the green, nothing, yellow, nothing, and red. So what that means for a simple deduction is this brown ground wire hooked to the battery actually becomes the red ground wire out here on this plug. So you can use the same methodology as far as with your harness then, where you actually pick up, say, the red wire, and you touch a red wire and you have a signal so that you can test the individual sprayer harness as well. We're going to go ahead and plug those in now because we want to make sure that we're getting a circuit all the way from the power source right here all the way to where the valves would plug in out here. So again, we're going to take one lead and we're going to connect it to the red. We're going to connect it to the brown wire, and we're going to touch one of the red wires, and we have a signal. Okay, so we have it connected here, and what we're looking for is power running from the wires, the positive and negative, all the way out to the end where they connect to the solenoids. So at this point, we're going to go ahead and we're going to hook up to the positive wire here, and we know that like the black and the blue, and we have a signal. And we come over here and we hit a red wire. I've got a red wire which is supposed to be ground, and I've got the positive wire here, so I'm going to check this. I've got a negative, and I do have a negative. I've got a negative and a negative, and I go back to the positive and touch this red wire again, and these red wires are all hooked back into the positive. What that indicates is that somewhere within this wiring harness, we have a skinned wire where the positive and a negative and the negative wire are actually making contact. So that would be where you would want to start to look for your fault at that point. So you can go through and do your troubleshooting with a meter like this. The other method is live testing, which as I said, we need some sort of a power supply, and what we're going to do is we're going to go ahead and we're going to turn this one on. We have our 12 volts. Your meter, you're going to have to switch this back to DC voltage, which is usually your voltage with the straight line. And then we're going to go ahead and we're going to tie into the positive and the negative so that we have our controller. We're going to turn our switches off here, and we're at 12 volts. So what we should be checking, what we should find out on these ends is if I hook to my black to a ground and I turn the blue on, for instance, I should get my 12 volts. And I do. Now, the yellow and the green wires, we weren't getting any voltage on, and those wires for TIR happen to be for our pressure regulator, and you can see I'm still getting no voltage. But if I come over to the pressure switch and I push it in the up position, I'm getting a positive 12. So what that indicates at this point is the green wire is actually the positive in the up position, but when I push it in the down position, it's a negative 12. So that means the switch is actually reversing the polarity of these two wires between positive and negative. But both wires are working because I've got the 12 volt positive and I've got 12 volt negative. So I don't have any problems with those. Now we go back to what we were looking at earlier, where I actually had a ground wire that was somewhere shorted within the positives. Now, on this power supply, I have the ability to actually see the amperage. So what I can do is actually turn them on switch by switch, and there's nothing happening with that one. And all of a sudden I'm drawing 2.5 amps, but I don't have anything connected to it. I go to the next one and I'm at 0. So at this point in time, what I need to figure out is what's wrong with the center boom, because it's obvious that the center boom, that particular wire, which happens to be brown, is actually hooked, in this case, to the ground wire, but it could be that they were skinned right here and making contact. So that's what you want to look for there. Now, I've gone over everything that would be covered on a benchtop simulation, and I can guarantee that most systems are not going to fail and need testing where you have the control box right here, you have your joint right here, and you have your ends loose right here. So what do you do when you're out in the field and you don't have the meter, you don't have a high dollar power supply to do all this testing for you? Well, you can still do the testing. We can do it live. I want to show you, before we get into the live though, one final version of the ohms, because we do get this question a lot is, well, is it my solenoid? Well, the solenoids can be tested by simply putting it down and going back to the solenoid video, which you can review in more detail. Voltage equals your amperage, which is 2 here. We've got 12 volts times the resistance. So we should have a resistance of 6. So in this case, I'm going to have to change the function. And I get a resistance of 5.8, 5.9, or 6. On this particular solenoid, we're going to go ahead and check it. I get a resistance of 7.0. 12 volts divided by 7.0 means it's 1.8 amps that this one is drawing, which that would indicate that it may not have enough power to actually open the solenoid, so this could be a potential problem. Then on this particular solenoid, we're going to go ahead and check it. And it's registering that I have continuity, but it's showing basically 0. So if I go back and imply that we've got at least 1 for the resistance, it's going to be 12 divided by the 1, which is 12 amps or more is going through this solenoid, which is going to indicate why you would possibly be blowing a breaker in the main control box. So this solenoid is definitely bad. So now we're going to move on to the live testing, because the failure is going to occur when you're farthest away from any one of these resources that I've used for the testing thus far. But you can do the testing live with a screwdriver by simply removing the solenoid from the top of the valve base, making sure that the plunger and the spring and the seal disc are all basically clean and operational, that they move freely within that. And then what you can do is go to your cab, turn all of these switches on, make sure you disconnect everything from the valves as soon as possible, because the 2 amps will be flowing through all of your active coils for as long as you have the testing going on, and we don't want to heat up the coils. Now, in this case, my spade connectors don't work well with the weather pack. So we do have an option at TIR that we sell where you can upgrade to the weather pack and more directly the E-chip, which is simply by plugging in the a positive wire into the positive terminal of the weather pack, and then you plug the negative wire into the negative on that, and now we have the adapter. So if you're out in the field, you would have the right connectors. You've taken the one solenoid apart that you think is giving you the problems. You've got all your boom switches on at this point. So what you can do is hold this plunger like this and go ahead and connect it, and you see we have power. Now let's go back to the solenoid that I said is basically dead, and we'll use the same 2 wires. If I can get this undone, and we're going to hook 1 over 1, and then we're going to go ahead and we're going to simulate the same testing where I put the plunger in there, and then I'm going to make contact. and that's plugged in, and the solenoid is not working. So out in the field, you can determine if you've got actually a dead solenoid with simply your control box, and you can do it by yourself by simply using and making sure that all of these wires are live, so that when you go to hook it up, that you have good ones and you can find out if you've got a bad one. Thank you.
Texas Industrial Remcor, quality valves and controls today and tomorrow.